This video is about decomposition reactions and how to predict products. In decomposition reactions, one substance breaks down or decomposes into two or more substances. Many require the use of heat, light, or electricity to do so. The way that you know that you have a decomposition reaction is you are always going to have one reactant only. The whole point of a decomposition reaction is that this one compound is going to break down into two or more parts. A Hollywood example of this would be The Breakup. You have Angelina Jolie and Brad Pitt. They break up, decompose into separate entities, right? So you have Angelina by herself and Brad by himself. The general scheme of decomposition reactions is as follows. A and X stand for generic elements. Together they're a compound, and then they split into their representative elements. Now let's go through several different examples of decomposition. You can have a decomposition of binary compounds. When I say binary, I am referring to two elements only to make up the compound. Electrolysis of water is an excellent example of a decomposition reaction. In electrolysis, you use electricity to break down or decompose in this case, split water into hydrogen and oxygen. An electric current is needed to do so. You cannot decompose water simply by heating. When you heat water, you simply turn the water from a liquid into a gaseous vapor. Let's see if you can write the balanced equation for the electrolysis reaction above. Water splitting into hydrogen and oxygen gas. So water, H2O, is going to be the only reactant, and it is going to split into hydrogen and oxygen gas. Do not forget about Hofbrinkel. Hofbrinkel is the mnemonic device that we use to remind us of the diatomic elements. These elements all come in pairs, so a subscript of 2 is needed in each case. Now, once we've got each of the parts correct, then we need to go back and balance the equation. Since I have 2 oxygen on the right-hand side, on the product side, I need to also have 2 oxygen on the reactant side, so I'm going to put a 2 as a coefficient. Now this changes my hydrogens on the reactant side to 4. So in order to have 4 hydrogens on my product side, I also need a 2 here. And now that is the balanced equation for the decomposition of water. To decompose metals, metal carbonates, that will produce a metal oxide and carbon dioxide gas. This is exactly the reverse reaction from the synthesis of metal oxides and carbon dioxide to make the metal carbonate. In this case, we have calcium carbonate, which is going to decompose into calcium oxide and carbon dioxide. Carbon dioxide, since it has a prefix, you do not need to worry about charges. However, in an ionic compound like calcium and oxygen, you need to make sure that you check the charges to make sure that they add up to equal 0. If they do not, you have to add subscripts. So please make sure that you always check your formulas as you are predicting products. In the next example, we have the decomposition of metal hydroxides. All except for group 1 metal hydroxides, they will give you a metal oxide and water. So calcium is the example that we use in this case also. In this case, we have 2 hydroxides because calcium has a +2 charge and hydroxide has a -1 charge. So 2 hydroxides are needed. When they split apart to get the metal oxide and water, the metal that is in the reactant side will have to be the metal that is in the product side according to the law of conservation of mass, and water will be the other product. In order to make sure that you have your formula balanced, make sure that you check charges between oxygen and whichever metal is present. The fourth type of decomposition reaction we will talk about are the decomposition of metal chlorates to produce a metal chloride and oxygen gas. Metal chlorates such as potassium chlorate, ClO3, with a -1 charge is a chlorate. So if you have a metal like potassium, which has a +1 charge, you will only need 1 potassium for every 1 chlorate. It will decompose to produce a metal chloride. Same metal, in this case is potassium. Chloride just means Cl. Check your charges, +1 and -1. And then you will create oxygen gas, which is part of Hofbrinkel, so do not forget the 2 subscript. After you get to this point, you need to balance your equation. Since I have 2 oxygens on the right, but I have 3 on the left, I'm looking for a common multiple of 6. So if I put a 3 in front of the oxygen, that will give me 6 oxygen on the product side. If I put a 2 in front of the potassium chlorate, it will give me 6 oxygen on the reactant side. In order to balance the potassium and the chlorine, I need to also have a 2 on my product side, and I should now be balanced. The fifth type of decomposition reaction is the decomposition of some acids into nonmetal oxides in water. One of the most famous in this particular case is carbonic acid. Carbonic acid is very unstable and does not like to remain in its acidic form. It will decompose very readily into carbon dioxide gas and water. And this is already balanced. The last type of decomposition reaction is a very specific one, and it is the decomposition of hydrogen peroxide into water and oxygen gas. Hydrogen peroxide is H2O2, and it will decompose into water and oxygen gas, O2, every single time. This is something that is probably most easily memorized. When you go to balance your equation, you will need a 2 in front of the hydrogen peroxide and a 2 in front of the water. The rest of the guidance on how to predict products is listed at the bottom of your guided notes section. If you have any questions, feel free to contact me and ask.